Hello guys. So today we are going to discuss maximization problems and how we solve maximization problem using linear programming method. Okay. Now what is a maximization problem? A maximization problem is actually a problem where we want to maximize or optimize in the way of maximizing the end result. Okay, so we are now going to understand this concept using the help of an example, and in this problem we are going to first discuss the constraints, the initial conditions and the points in the problem. We are going to understand the problem much properly, and in the next video we are going to see how we solve the problem using graphical solution. Okay, now, in the first question, in the question given here, it said that Reddy Mikks produces both interior and exterior paints from two raw materials, okay, M1 and M2. So these are the two raw materials. The following table provides the basic data of the problem. Okay, so we are given a data from which we are going to understand what the problem looks like. Okay, so we have two raw materials M1 and M2. Okay, and we are given a profit per ton which is expressed in the form of $1000, and we have tons of raw material per ton of exterior paint. We have tons exterior paint and interior paint. Okay, so we are given two options, which is exterior paint and interior paint, and we have maximum daily availability of tons of raw material. Okay, now in this, from this table we understand that we actually need 6 tons of raw material M1 for producing exterior paint and 1 ton of raw material M2 per to produce per a ton of exterior paint, and 4 tons of raw material M1 for producing per ton of interior paint, and 2 tons of raw material M2 to produce per ton of interior paint. Okay, and for this we have 24 tons of maximum daily availability of M1, tons of raw material of M1, and 6 tons of raw material M2 daily. Okay, and from this we have the tons present here, and we have $1000 profit per 5 tons of exterior paint, and we have $5000 profit per ton of exterior paint and $4000 profit per ton of interior paint. Okay, now we have understood the problem given in the table. Okay, now a market survey indicates that the daily demand for the interior paint cannot exceed that for exterior paint by more than 1 ton. Okay, so now market survey indicates that the daily demand for interior paint cannot exceed that of exterior paint by more than 1 ton. Okay, so the tons of interior paint can be greater than exterior paint only by 1 ton, of only 1 ton or less than that. Also, the maximum daily demand for interior paint is 2 tons. So we are given the maximum daily demand for interior paint, which can only be 2 tons. Okay. The Reddy Mikks wants to determine the optimum or the best product mix of interior and exterior paints that maximizes the total daily profit. Okay. Now we need to maximize the total daily profit so that we get the most optimum product mix of interior and exterior paints. Okay, now this is a maximization problem. We need to maximize the end result of total daily profit. Okay, now we need to understand some 3 basic components of the problem so that we can go ahead. Okay, so the three basic components are decision variables that we seek to determine. Okay, so we have some decision variables on which we are going to base our condition and solve the problem. Okay, now we have an objective or goal, that is we need to optimize, maximize or minimize. So this is a maximization problem. So our final goal is to maximize the end result. Okay, and we will be given some constraints so that the solution must satisfy those constraints and finally obtain the final proper result. Okay, now we need to define the decision variables. Okay, so we are given a problem and we need to determine the decision variables. So determination of the daily amounts to be produced of exterior and interior paint. Now if you can see from the table, our profit is determined on the number of tons of exterior paint. Okay, so from 1 ton we have $5,000 profit. So how much tons of exterior paint must be produced in an optimized way so that we can actually maximize the profit and get the best product mix of exterior and interior paint. Okay, now let's say we have X1, which is tons produced daily of exterior paint, and X2, tons produced daily of interior paint. Okay, of interior paint. X1 is for exterior paint and X2 is for interior paint. Now our objective or the goal is to maximize, okay, of Reddy Mikks, which is a company, is to maximize, I increase as much as possible the total daily profit of both paints. Okay, so if we are manufacturing both the paints, we need to maximize the profit. Okay, so how much we are going to produce according to our constraints so that we can finally maximize the end result. Okay, so two components of the total daily profit are in terms of X1 and X2. Okay, so we need to find the profit in terms of X1 and X2, because if you see in the table, we are given the profits in terms of exterior paint, tons of exterior paint, and profit in terms of tons of interior paint. Okay, so we have defined X1 as X2 as the tons produced daily, which is an unknown figure till now. Then we are going to find the profit from the exterior paint. Okay, so which is 5x1. Okay, so 5x1, why 5x1? See here we have $5,000, which is 5 is expressed in terms of $1,000. So 5x1. So 5 into x1 means 5 into number of tons of exterior paints produced daily. Okay, now we have profit 5x1, which is from exterior paint, and 4x2 in the similar manner interior paint is 4x2. So 4 into number of tons of interior paint produced daily in terms of $1,000. Okay, so these are in $1,000. So to reduce the calculation, they have actually reduced the figure from $1,000. They have taken only 5. Okay, now let's say if we are going to find the objective function, okay, on which we need to work. So let's say Z, which is the total daily profit. Okay, the most maximized total daily profit we will be getting by solving this equation. So let's say Z is the figure in thousands of dollars, and the objective is to maximize Z is equal to 5x1 plus 4x2. So 5x1 is the profit from exterior paint and 4x2 is the profit for interior paint. And if we sum up the figures, so then Z is equal to 5x1 plus 4x2. Okay. Now, this is the objective function. Finally, we have got an objective function which we get like this. So this is the final objective function. This is the final objective function on which we are going to work. Okay. Now let's say we are going to now work on the constraints of the problem. What restrictions we are given in the problem, so that we need to find a solution according to those restrictions. So verbally, the raw material usage can be expressed as usage of raw materials by both paints is less than equal to maximum raw material availability. Okay. Now from here we can see that we are given a maximum daily availability. Okay. Now we cannot exceed that. Okay, because it's the maximum daily availability, and if we exceed that, we actually will not get the produce of raw material. Okay. Now the first post constraint is usage of raw material by both paints is less than equal to maximum raw material availability. So from here we get that usage of raw material M1 by both the paints is 6x1 plus 4x2. Now x1 and x2 are the daily produced tons of interior and exterior paints. Now 6x1 plus 4x2. Okay. Now we get here that 6x1 is the usage of raw material M1 by both the paints. Okay. So x2, 6 into x1. So 6 into tons of raw material M1, sorry, tons of raw material of exterior paint produced into x1. Okay, x1. Okay, so tons produced daily of exterior paint, which is 6x1 and 4x2. So 4x2 is number of tons of raw material M1 required per ton of interior paint. So number of tons of interior paint required is x2, and the number of tons of raw material M1 required per ton of interior paint is 4. So we get 4 into x2, which is the usage of raw material M1 required by both the paints. So 6x1 plus 4x2 tons per day. Okay. Now usage of raw material M2, in the similar manner we can say that from the figure 1x1 plus 2x2. Okay, 1 into x1. So x1 is the number of tons of exterior paint produced, and x2 is the number of tons of interior paint produced. So 1x1 plus 2x2. Okay, so here we get 1x1 and 2x2 tons per day. So these figures cannot actually exceed the maximum raw material availability. Okay, so next we will see maximum daily availability of M1 is 24 tons. So you can verify from the table the maximum daily availability of M1 is 24 tons and M2 is 6 tons. Okay, so 6x1 plus 4x2 is less than equal to 24. Okay, so this figure cannot exceed 24, and this figure cannot exceed 6. Okay, so these are restrictions in terms of raw material availability. So we are given some restrictions after the problem. So here we see that a market survey indicates the daily demand for interior paint cannot exceed that for exterior paint by more than 1 ton. So x2 minus x1. So x2 is the daily tons of interior paint produced, and x1 is the daily tons of exterior paint produced. So x2 minus x1 cannot exceed 1. Okay, so x2 is greater than x1 by only 1 ton. Okay, so here you can see that the daily production of interior paint cannot exceed that of exterior paint by more than 1 ton. So x2 minus x1 is less than equal to 1. Now the second restriction is that here we can see in the problem that we are given a maximum daily demand for interior paint is 2 tons. So x2 is less than equal to 2. So here we get that x2 is less than equal to 2. And from this type of problem we can see that x1 and x2 can never be 0, because we have some production going on in this company. Okay, so x1 and x2 is always greater than equal to 0. Now, if we sum up the constraints and the problem, finally the problem is summarized as follows. We need to maximize a objective function, which is the total profit, total daily profit, which is 5x1 plus 4x2. And these are the constraints which are given in the problem. So we need to maximize it in terms of these constraints. Okay, fantastic. Now x1 is equal to 3 and x2 is equal to 1. Okay, now if we actually take this in terms of linear equations, like 6x1 plus 4x2 is equal to 22, which is less than equal to 24. Okay, so if we take some, say, a dummy solution like x1 is equal to 3 and x2 is equal to 1, and we place this dummy solution in these constraints, and we find out the final solutions, like 6x1 plus 4x2 is giving 22, which is actually less than equal to 24. And if we apply this solution in the second equation, we have 5, which is less than 6, less than equal to 6. And in this we have x2 minus x1, which is minus 2, which is also less than equal to 1. And x2 is 1, which is less than 2, less than equal to 2. And x1 and x2 both are greater than 0. So this is some dummy solution we have put to finally get some type of solution, but this is not required. So we need to find out this problem finally from the above descriptive problem. Okay, we need to maximize an objective function subject to some constraints. So in the next video, we'll be seeing the graphical solution to the problem and how to construct the graph and compute the feasible solution space, and finally compute the what is the actual solution of x1 and x2. Okay, so how much tons of interior and exterior paints we need to produce so that we maximize the final total daily profit. So thank you for this video.